So, a phase change is a change based on temperature and pressure of the states of a substance. Increased temperature increases the kinetic energy, which is the movement of the molecules after a force is exerted on it. And by increasing kinetic energy, the movement of each individual molecule gets faster, increasing its enthalpy, because the individual movement of each molecule is what enthalpy is.
That was enthalpy. Entropy, on the other hand, is the randomness in which the molecules of a substance move. For example, gas has the highest entropy of any phase because the molecules move most rapidly and with the most random direction. Liquid, on the other hand, has a higher entropy than a solid but less than a gas. In a solid, the molecules barely move at all, they simply vibrate in place. In a liquid, they move, but not in a rapid and random motion as in a gas, which means that liquid has a higher entropy than solid and gas higher than liquid. This graph indicates different phase changes at different temperatures and pressures. Along the y-axis, we have pressure. Unfortunately, it's not labeled. And on the x-axis, we have temperature. This is the phase diagram of nitrogen. As you can see, all the temperatures are very, very cold, which makes sense seeing as liquid nitrogen typically is around -200 degrees Celsius. We're going to try to find the triple point of nitrogen in this experiment. This is where the solid, liquid, and gas state exist equilibrium, and we are able to see all three states at once.
So vapor pressure, one of the parts of this experiment, is when it's the pressure exerted by a substance when it is vaporizing or going into a gaseous state. And this is what happens like when a substance boils, which is why the temperature doesn't raise anymore after water boils. Another part about boiling is that the atmospheric pressure exerted by the surroundings must be equal to the vapor pressure. This makes it so the substance can be released from its liquid state into the gaseous state.
A vacuum is a device that is used in the lab to remove pressure from a certain area, so the pressure inside of the actual vessel is less than that of the ambient pressure in the room. This makes it so we can have a low pressure environment in a lab setting. This experiment will be finding the triple point of nitrogen.
Before we actually do the experiment, let's talk about some common uses for liquid nitrogen outside of the lab. Sometimes it is used by bartenders to create sensational looking cocktails. Other times it can be used to keep things cool, like ice cream. It can also be used by a medical professional to freeze off warts. As you can see, we've placed the boiling liquid nitrogen in a vacuum pump. There is a small styrofoam cup around the bottom of the beaker in order to insulate the coolness of the nitrogen to keep it from evaporating. At room temperature, liquid nitrogen boils, hence the violent movement of the liquid in the vacuum pump. As the pressure is increased, the behavior of the liquid nitrogen starts to change. It begins to boil less aggressively, and the gas begins to start to settle and return to its liquid state. Some safety precautions to take in this experiment are to always wear glasses, as something could always go wrong with the vacuum pump. Also, liquid nitrogen is incredibly cold. It is important to wear gloves when handling the substance. As you can see now, we are approaching the triple point, as the boiling has become almost like a slow simmer, and the gas is no longer being produced in such a rapid manner. It is hard to see liquid nitrogen in its solid form, because it looks just like ice or just like the liquid. It's the same color. As you can see here, we're starting to get a little bit of bubbling on the top and a layer of solid over the liquid, yet it still exists in its gaseous state. This is the triple point. Here I have highlighted where the liquid is at the bottom in the blue, and then the gas in the yellow, and the pink indicates the solid, which kind of looks like an iceberg.